Hello, algebra. Welcome back. And today I'm going to talk to you very briefly about linear equations in one variable. So, to start off, I want to tell you that a linear equation is an equation of a straight line. So when you graph a linear equation in one variable, you get a straight line. You can have linear equations in more than one variable, and then we are going to do some of those later. But for this video, I'm just going to tell you a few basic ones. So let's just give you an example. And I think you guys are familiar with this type of equation. Let's say I say 3x equals 2x plus x. So let's go ahead and simplify this equation. 2x and x are like terms. So I can say 3x is equal to 3x. And you might go, duh, 3x and 3x are the same thing. So what this is called when you have an equation that is true no matter what x is, you call that an identity equation. And what I mean when I say it's true no matter what x is let's come up with some, that's not a good way. Let's come up with some values for x. Let's say x equals 7, and I want to plug that into the equation. So then I have 3 times x equals 3 times x. And in this case, I'm saying, you know what? X is equal to 7. So 3 times 7 is equal to 3 times 7, and that gives me 21 equals 21. And that's a true statement, right? What if I did a different value for x? What if I said x is equal to 4? So then I'm just plugging 4 into this equation. 3 times 4 equals 3 times 4. So that would say 12 equals 12. And that's a true statement. And so I think you get the point here. No matter what I plug into this equation, no matter what value of x I use, I'll always have 3 times something equals 3 times something. And that's called an identity equation because it's always true. No matter what I put in for x, this is an identity equation because sorry, gang. I can't figure out how to turn that setting off. If any of you know how, hit me up in those YouTube comments. I'm not too proud. So because 3x is equal to 3x, no matter what x is, that's called an identity equation. So well, we could have other kinds of equations. We could have a linear equation in one variable that's not an identity equation. Let's look at another example. So we could have something like 3x plus 5 equals 3x minus 20. And let's say we wanted to solve this equation. We want to know what value of x makes this statement true. So when we solve equations like this, we try to isolate the variable by applying inverse operations to each side. That's some real mathy math. I'll show you the example of what I mean here. So I notice that I have a statement with a variable right here, this 3x, and then I have a constant being added to it. And then on the right-hand side of my equal sign, I have a statement with a variable and then a constant being added. So what I'm going to try to do is collect all of my constants on one side of the equal sign and all of my variables on the other. So the first thing I'm going to do is I'm going to try to address this positive 5. I would like 3x to be by itself. So what I'm going to do is subtract 5 from each side of my equation. And here I can say that positive 5 and negative 5 add up to be 0. So this is 3x plus 0 equals 3x minus 25, because negative 20 and negative 5 add up to negative 25. And then 3x plus 0, I don't really need to write that 0, so I can just say 3x equals 3x minus 25. And now I'm going to try to move all of my statements with a variable. Oops, sorry, I'm supposed to be the highlighter. All of my statements with the variable, 3x and 3x, over to one side. So again, I'm going to subtract 3x from each side. And then something kind of strange is going to happen, I'll warn you. 3x subtract 3x becomes 0. So I have 0 is equal to negative 25. Huh? That's not true, right? That is a big, fat, false statement. 0 is not equal to negative 25. So here, something strange happened. It's not true, and so this has a special name also. We would call this an inconsistent equation. So this is an inconsistent equation. Because no matter what x is equal to, so no matter what x is, 0 is not equal to negative 25. So no matter what I put in for x, nothing can make this a true statement. So we would call it an inconsistent equation. This is an inconsistent equation. All right, so those are the two strange cases, and you guys are probably trying to kill me right now. You're like, Sarah, just show me a normal equation. Just show me a normal one. Okay, so here's a normal equation. It's not inconsistent, and it's not an identity equation. 2x plus 7 is equal to 19. And so I want to figure out what is the number that I can plug into this x that's going to make it true. So what I would do if I were you is I would try to figure out briefly just what number would work here. Think about it. Don't try to solve the equation. Just see if you can do it mentally. Like what if, I don't know, let's start off with a guess. What if x is 5? Does that work? 2 times 5 is equal to 10. 10 plus 7 is equal to 17. So, okay, it doesn't give me 19. That didn't work. But we're pretty close. In fact, we're only 2 away. Wow, that's irritating. This iCloud thing has got to go. And so, what if I did, as a guess, x equals 6. So then 2 times 6 plus 7 would be 12 plus 7 would be 19. Yay! So you can do guess and check to kind of figure these out. But there's a methodical, analytical way to solve this type of problem. Analytical means there's a set of steps that you can follow that will give you the same answer every time. You could guess on a lot of these and know, and that's a totally fine way to solve it. But an analytical method is good to have in your back pocket because then you know no matter what equation I throw at you, you could solve it. Even if it has fractions or decimals or something else that's a little bit harder to guess and check. So here is what we're going to do. We're going to use properties of inverse operations here to figure out what x is. So our goal is to get this variable x and isolated it by itself. So what's happening to x right now? Well, we have this number 2 that's multiplying into it. And then after we multiply those two numbers together, we're adding 7. So we're going to use inverse operations to each of the things that's happening to x. So to deal with adding 7, the opposite of addition is subtraction. So we're going to subtract 7. And then because we have this equal sign here, we want to do the same thing to both sides of the equation. So we're going to subtract 7 from each side, and that's going to leave us with 2x equals 12. Now we still have 2 multiplying our x, and we would like to get the x by itself. So the opposite of multiplication is division. So I know I'm going to divide both sides by 2 and by 2. And I know that 2 divided by 2 is equal to 1. So I'll just be left with x here. And 12 divided by 2 is equal to 6. So x is equal to 6 would be our final answer. That's one example of a linear equation. All right, let's do one that's a little bit more tricky. You might not be able to guess this one right away. And then that'll be enough for this video. So let's do -2 times 3x minus 1 in parentheses plus x equals 14 minus x. So I'm going to highlight the x. This is the variable that we want to get isolated on one side of the equal sign. And here's all the places I see x. So I think the first thing to do here would be actually to deal with these parentheses. As once I get these parentheses dealt with, these parentheses handled, I'll be able to just add and subtract everything on the left-hand side of the equation. So that's what I'm going to do. I'm going to distribute my -2 in here. So I have -2 times 3x to get -6x, -2 times -1 to get +2, and then I've handled this statement. And I just copy down everything else that I haven't had a chance to deal with. And the nice thing about doing it this way is now I have -6x and x here on one side, and these are like terms. And then I have a -x on the other side of the equation. But I see that the operation combining everything over here is addition. And addition is commutative, which means I can change the order. So I could say -6x plus x plus 2 is equal to 14 minus x. And now I can go ahead and add -6x and x because those are like terms. And so I get -5x plus 2 equals 14 minus x. So again, here's my variables, and I want to get them together so that I can combine those like terms. And my other like terms here are just these constants, and I want to bring them together so that I can combine them. It doesn't matter which one I do first, so I'm going to do the variable first. I'm going to add x to each side. I'm choosing to add because that's the inverse operation to subtraction. And then I have -4x plus 2 is equal to 14. Now I have these like terms that are constants that I want to collect. So I'm going to subtract 2 from each side. I'm choosing to subtract 2 because it's the opposite of addition. And then I'm left with -4x equals 12. And now here I still have only one variable now. Oy, I was trying to highlight. I still have only one variable. And what's happening to that variable is I have a constant multiplier of -4. So to undo multiplication, I want to divide by -4. Because -4 divided by -4 will just leave me with 1x. And so I'm doing it to the left side of the equation. That means I have to do it to the right as well. So -4 divided by -4 is equal to 1. So I'm left with 1x. And then on the right-hand side of the equation, I have 12 divided by -4. A positive divided by a negative should give me a negative answer. And 12 divided by 4 should give me 3. And so for this equation, I have x is equal to -3. And if you want to check your work, which is not a bad idea when you have an equation like this, is you can go back to your original statement and plug in your answer for x and see if what you get is true or not. So let's go ahead and try that. I'm going to plug x into this equation. So my original equation that I started off with was -2 times 3x minus 1 plus x equals 14 minus x. And so I'm claiming that x is equal to negative 3. So I'm going to go ahead and everywhere that I have an x, I'm going to plug in the number negative 3. So I have negative, oops, not the highlighter this time. Ay, ay, ay. So I have negative 2 times 3 times the x value of negative 3 minus 1 plus negative 3 equals 14 minus negative 3. And then I just simplify what I have here. So I'm going to use my order of operations. So 3 times negative 3, I'll get negative 2 times negative 9 minus 1 inside parentheses. Minus 3 equals a negative is the same as a positive. So this becomes 14 plus 3. Then I have negative 2 times negative 10 minus 3 equals, I'll go ahead and simplify to get 17. Negative 20 minus 3 equals, oops, I made a mistake. Do you see it? I have negative 2 and negative 10. So a negative times a negative should be positive. Let's just get rid of that negative sign there. So then I have 20 minus 3 is equal to 17. And then I get 17 is equal to 17. Because this is true, I know that my answer is correct. Yay! Because I ended up with a true statement when I plugged that in, I can feel confident that my answer of x is equal to negative 3 is correct. So that gives me a smiley face. Yay! All right. I hope you guys are well. Stay safe.